area. A solid cone of height 12 centimeter and radius 9 centimeter is recast into a solid sphere. Calculate the surface area of the sphere. Now the volume of a cone is taken to be a third pi r h. Now you can get that by having a third 22/7 multiplied by 9, the radius has been given 9, and multiplied by the height which has been given 12. So the volume of that cone is 1018 and 2/7 centimeter cubed. Now, if that cone is to has been recasted into a sphere, it means the sphere has the same volume. Now, the volume of a sphere we get it by taking 4/3 pi r cubed. So we equate 1018 and 2/7 is equals to 4/3 multiplied by 22/7 multiplied by pi cubed. We divide 88 and 21 on both sides and take the cube root. We get r to be 6.2403 centimeter. Now, the surface area of a sphere is taken to be 4 pi r squared. We have found r, we know the pi, so we can find the surface area of the sphere is 4 times 22/7 multiplied by 6.2403 squared, and we get it is 489.55 centimeters squared. A cylindrical can has a hemispherical cap. The cylinder and the hemisphere are of radius 3.5 centimeter. The cylindrical part is 20 centimeter tall. Taking pi to be 22/7, calculate the base of the circular area, B, the area of the curved surface, C, the area of the curved hemispherical surface, and D, the total surface area. Now, the area of a circular base of a cylinder is taken as pi r squared. So we have 22/7 multiplied by 3.5 squared, we get 38.5 centimeters squared. Now the area of the curved surface of a cylinder is taken as 2 pi rh. So we have 2 multiplied by 22/7 multiplied by 3.5 multiplied by 20, and we get 440 centimeter squared. Now the area of the curved surface of a hemispherical surface is taken to be 2 pi r squared. So you take 2 times 22/7 times 3.5 squared, and you get 77 centimeters squared. Now the area of the total can will be taken by taking the area of the circular base, the area of the curved surface, and the area of the hemispherical surface, which is 38.5 plus 440 plus 77, giving us 555.5 centimeters square. An open right circular cone has a base radius of 5 centimeter and a perpendicular height of 12 centimeter. Calculate the surface area of the cone. The area of a surface, the surface area of a cone is taken to be pi r l, where l is the slanting height. Now pi is 3.142 multiplied by the radius given as 5, and the slanting height we shall find it by having the square root of 5 squared plus 12 squared. Now, what it means is that the radius and the perpendicular height forms a right angle triangle with a slanting height. So the slanting height is the hypotenuse, and using the Pythagoras theorem, the hypotenuse can be found by uh, squaring the height, squaring the base radius, which is the same as just the base to the height of 12, and then you get the hypotenuse. The hypotenuse is the slanting height of the cone. Having found it, it is 13. Then multiply by the rest, the radius and the pi, we get the surface area to be 204.23 centimeters square. A girl wanted to make a regular octagon of side 14 centimeters. She made it from a square piece of card of size y centimeter by cutting off 4 isosceles triangles whose equal sides were x centimeter each, as shown in the figure below. A. Write down an expression for the area of the octagon in terms of x and y. B. Find the value of x. C. Find the area of the octagon. Now, the details have been illustrated above. Below, I'm sorry for that. The octagon the girl wanted to make has been illustrated. We have x, the size of the isosceles triangle the girl made. So it means the base length of that isosceles triangle is equal to 14 centimeter, because it has to be a regular octagon, or the size of that octagon should be 14. Now let's find y squared. Y squared is equals to half base height times 4. Now we have the base as x, the height as x, because you can see those equal sides of that isosceles triangle. The equal sides of that isosceles triangle fall on a right angle triangle. So our y squared becomes y squared minus 2x centimeter squared. Now we know, but B, we know a squared plus b squared is equals to 14. But since that's an isosceles triangle, the part a squared is equals to b squared. Now a squared is equals to b squared, which is also equal to x squared, because a is x and b is also x. Now, which is equal to 14 squared divided by 2. So x squared is equals to 98. So x is equals to the square of 98. Now let's find the area of the octagon. Now the area of the octagon is y squared minus 2 x squared, as we found it in part A. Part A, we are finding the area of the octagon when we are finding y minus our base I times 4. So we are taking the whole square before the 4 isosceles triangle were cut, and then less now the 4 isosceles triangle to find the area of the octagon, and we found it to be y squared minus 2x squared. Now substituting the values, we know that x is equals to the square of 98. So substituting the value, we find that y squared is equals to 1442.37, and x squared and 2x squared is equals to 196. So the area of that octagon is 946.37 centimeters square. The figure below shows an octagon obtained by cutting off 4 congruent triangles from a rectangle measuring 9.5 centimeter by 16.5 centimeter. Calculate the area of the octagon. Now, the area of the octagon, we shall take it by having length times width of the original rectangle less the area of the triangles that have been cut off the rectangle. There are 4, so we shall take half base height times 4. Now the area of the original rectangle length times width, it is 19.5 multiplied by 16.5. The area of each of the 4 triangles that have been cut is a half times the base, which is 6, times the height, which is 4.5, and then since there are 4 of them, we multiply by 4. So you get that the original rectangle had an area of 321.57. There's now the area of the cut off triangles, which totals to 54. We have now the area of the octagon to be 267.57 centimeters squared. Two sides of a triangle are 5 centimeters each, and the angle between them is 120 degrees. Calculate the area for the triangle. Now, the area for the triangle can be taken to be a half base times height. Now, half the base is the same as 5 multiplied by sine 30 degrees, and the height is the same as 2 multiplied by 5 cos 30. So solving, we get that the area of the triangle is 10.825 centimeters square. A piece of wire, p centimeter long, is bent to form the shape shown in the figure below. The figure consists of a semicircular arc of radius r centimeter and 2 perpendicular sides of length x centimeter each. Express x in terms of p and r. Hence, show that the area a centimeter squared of the figure is given as a half pi r squared plus an eighth p minus pi r squared. Now, the length of the arc xx is equals to the length of the wire, the length x, or the length of the radius, is equals to the length of the whole wire minus the length of the arc, and then divide by 2, we get the radius, or x. Now simplifying, p minus the length of the arc is 2 pi r multiplied by a half. because that arc is 120 degrees. Then divide by 2, we get the value of x. So x is a half into p minus pi r. Now what about the area? The area you get the area of the triangle and the area of that part of the circle. So that part of the circle is a half pi r squared minus half base height as the area of the triangle. So simplifying, knowing that h is equals to x, or the radius, we have half is equals to half into p minus pi r. Now area of the figure, what will be the total area of the figure? It will be a half pi r squared plus a half into a half p minus a half pi r squared. So a half p minus a half pi r squared, it should be squared. Solving further, you find that the area becomes a half pi r squared plus 1 over 8 into p minus pi r squared. The figure below represents a kite ABCD. AB is equals to AD 15 centimeter. The diagonal BD and AC intersect at O. AC is equals to 30 centimeter and O and AO is equals to 12 centimeter. Find the area of the kite. Now the area of the kite, we can find it by finding the area of triangle ABD and also finding the area of triangle BCD and then adding them together. So the area of triangle ABD is equals to a half base times height. A half multiplied by the base. The base will be 2 into 15 squared minus 2 into the square root of 15 squared minus 12 squared. Now what we mean here is that at O, OA is the height of that triangle, and OD is the base of triangle ADO. So to find the base OA, we have to take 15 squared, which we know AB or AD is 15 squared minus 12. We have been given the length OA is 12. So having squared 15 less the square of 12, we find OD. But remember, the base of that triangle ABD is BD. So having found OD, we have to multiply by 2 to get BD. That's why we are taking the base to be 2 into the square root of 15 squared minus 12 squared. Multiplied by the height which have been given is 12. We get 108 as the area. Now for the other triangle, that is BCD, we have been given the height as 12. The base length will be the same since they share with that of the triangle ABD, so it will be the same. And then multiplied by half, we get the area of that triangle to be 162. Now the area of the whole kite ABCD will be the area of triangle ABD plus the area of triangle BCD, which is 108 centimeter centimeter squared plus 162 centimeter squared, which gives us 270 centimeter squared. The figure below represents a pentagonal prism of length 12 centimeter. The cross section is a regular pentagon center O whose dimensions are shown below. Find the total surface area of the prism. Now, a pentagon forms at least, sorry, not at least, it actually forms 5 isosceles triangles. Now, since that is a prism, we have 2 pentagons at the end, so we shall have 10 isosceles triangles. Now, the other part of the prism, there are just 5 rectangles. Now, so the area of the pentagon will be equal to the area of 10 isosceles triangles plus the area of 5 rectangles. Now, the area of 10 isosceles triangles will be 10 multiplied by half base times height. Now, we have the base to be 5 because the side of each pentagon has been given. The figure below is a polygon in which AB is equals to CD is equals to DE is equals to FA, which is equals to 12 centimeter. BC is equals to EF, which is equals to 4 centimeter, and angle BAF is equals to angle CDE, which is equals to 120. AD is a line of symmetry. Find the area of the polygon. Now, the area of the polygon is equals to area of triangle ABF plus area of triangle CDE plus area of rectangle BCF. Now, this is because triangle ABF and triangle CDE are equal. The area will be similar to 2 multiplied by half base times height multiplied by the length, plus length times width. Now, 2 multiplied by the half base of those 2 triangles is h sin 30, and half the height is 2h cos 30, and the length is 2h cos 30 times the width, which is 4 centimeters. Now, solving for that, we find that the polygon has an area of 207.84 centimeters squared. The length of a solid prism is 10 centimeters. Its cross section is an equilateral triangle of side 6 centimeters. Find the total surface area of the prism. So the prism, we have equilateral triangle on both sides. So there are 2. So we shall have 2 half base times height, and the other side that joins the triangles, there are just 2 rectangles. So plus 3 length times width. Now we know the base, but the height we can calculate it by taking 3 times 60. So having all the tests, we simplify and get that the surface area of the prism is 211.18 centimeter. A cylindrical piece of wood of radius 4.2 centimeter and length 1.5 centimeter is cut lengthwise into two equal pieces. Calculate the surface area of one piece. Take pi as 22/7. Now the surface area of one part of the log, we shall take pi r squared plus 2r multiplied by 150 plus a half multiplied by 2 pi times 150. Now if we solve for that, we get the area of a half a log to be 3,295.44 centimeter square. The figure below represents a model solid structure in the shape of a frustum of a cone with a hemispherical top. The diameter of the hemispherical part is 70 centimeters and is equal to the diameter of the top of the frustum. The frustum has a base diameter of 28 centimeters and a slant height of 60 centimeters. Calculate A, the area of the spherical surface. B, the slant height of the cone from which the frustum was cut. C, the total surface area of the model. Now the area of the hemispherical part is taken to be 2 pi r squared. Now equating those values, we get that the area is 7,700 centimeters square. Now the height of the frustum. Since the cone that was cut from the frustum and the original frustum are identical objects, we shall have the height of the original frustum. Let's say it is 60 plus x, and the cone that was cut off, the inside to be x. So that's a linear scale factor. So if we equate to what we have, the base diameter, we have that 60 plus x is equals to now the larger diameter, which represents the diameter of the original cone 70, and x, the upper diameter, which represents the diameter of the cut cone. So you find x to be 40. Now 60 plus x, we get 100. So that is the slant height of the original cone before the frustum was cut from it. Now, the last part I've been told to find the surface area of the model. The surface area, we shall take the area of the hemispherical part. We shall take the area, the surface area of the slanting part the frustum, and also the surface area of the base. So if we take the surface area of all those three parts, we get the surface area of the whole model, which becomes 17,000. Is it 17,000? 17,556 centimeter squared. The figure below is a model representing a storage container. The model, whose total height is 15 centimeter, is made up of a conical top, a hemispherical bottom, and a middle part which is cylindrical. The radius of the base of the cone and that of the hemispherical part are 3 centimeter. The height of the cylindrical part is 8 centimeter. Therefore, calculate the external surface area of the model. That's A being the total storage container has a total height of 6 meters. The outside of the actual storage container is to be painted. Calculate the amount of paint required if the area of 2 meters square requires 0.75 liters of paint. Now the surface area of the model, we shall take 2 pi r squared to be the surface area of the hemispherical part, and then 2 pi rh to be the surface area of the cylindrical part, and pi rl to be the surface area of the conical part. Now if we calculate, we get that the surface area of the model is 254.57 centimeters square. Now we have the linear scale factor, 15 centimeter representing 6 meters, because our model has a height of 15 centimeter, and now the actual container has a height of 6 meters. So it means that 15 centimeter is representing that height of 6 meters. Now we have the area of our model. Let's approximate it to the nearest whole number. It is 255 centimeter squared, representing 36 meter squared. What it means here is that having the linear scale factor, I've squared the linear scale factor, that is 15 squared to get 255, and I've squared 6 meters to get that 6 meters. So an area scale factor of 255 represents an area of 36 meters. Now let's relate the facts. 254.57 centimeter will represent 4.73 centimeter. Using our area scale factor, I have not calculated in the slide there, but if you calculate using our area scale factor, you'll find that the area we have gotten of the model represents an area of 40.73 of the actual storage container. Now, here we go. We ask ourselves, if 20 meters square requires 0.7 liters of paint, what about now the whole area of 40.73? We relate and cross multiply, we find that the whole model will require at least 1.527 liters of paint. A rectangular and 2 circular cutouts of metal sheet of negligible thickness are used to make a closed cylinder. The rectangular cutout has a height of 18 centimeter. Each circular cutout has a radius of 5.2 centimeter. Calculate in terms of pi the surface area of the cylinder. Now the surface area of the cylinder, we take it as 2 pi r squared plus 2 pi r h. Simplifying our formula because pi r is common, we shall have 2 pi r into r plus h. Now equating those values there and simplifying, we get that our surface area is 241.28 pi centimeter squared, because we have to leave our answers in form of pi. The figure below represents a plot of land A, B, C, D, such that AB is 85 meter, BC is 75 meter, CD 60 meter, DA is 50 meter, and angle ACB is 90 degrees. Determine the area of the plot in hectares correct to 2 decimal places. Now the area we can determine it by taking the area of those 2 triangles, triangle ABC, triangle ABC using the cosine rule, we can get the angle ABC. Now, having got the angle of ABC, we can use tan theta to get the length LC. Now, having gotten the length LC, we can it means we have the length of every dimension in that triangle. Now, having all the lengths, we can now use the hero's rule to get the area of the triangle ABC and ACD. Now, the area of triangle ABC, we shall add all the dimensions of the triangle, that is 85 plus 75 plus AC, which we found to be 40 meters, and then get a half of the total, that's the perimeter, and then getting a half of that perimeter, and then half of that perimeter is 100. So we take 100 into 100 minus 85, that's the one side, and then 100 minus 75 the other side, and then 100 minus 40. All the result of all this, we get the square root, which means that the area of triangle ABC is 1,500 meters squared. We do the same for the triangle ACD, and we get its area to be 992.156 meters squared. We add the 2, we get the area of the whole figure ABCD. Now, having gotten the area of the whole plot, we convert it into hectares because we have gotten the area in meters squared. We know 10,000 meters squared is equal to 1 hectare. What about the 2,492.156 meters squared we have found to be the area of the plot? If we let, we get that the plot is 0.25 hectares. A cylindrical solid whose radius and height are equal has a surface area of 154 centimeters squared. Calculate its diameter to 2 decimal places. Take pi to be 3.142. Now, the surface area of a cylindrical solid, we take it as 2 pi r squared plus 2 pi r h. But since r is equals to h, our formula shall turn to be 2 pi r squared plus 2 pi r squared. Now it means that everything is common there, so we simplify the equation to be 2 pi r squared into 1 plus 1. Further simplification is 2 pi r squared times 2. Now we put the variables there and find r. So r is 3.5. But since the diameter is 2 multiplied by r, the diameter is 7. The figure below represents a pentagonal prism of 12 centimeter. The cross section is a regular pentagon of 5 centimeter. Calculate the surface area of the prism correct to 4 significant figures. Now, a pentagon forms two isosceles. One pentagon forms 5 isosceles triangle from the center. We know from the center of a pentagon, if you divide by 5, we have the angle of each triangle. And now the base will be the side of the pentagon. So each pentagon will have a base of 5 and an angle at the center of 54. So since the pentagon is on both sides of the prism, so we shall have 10 triangles, because each pentagon has to have 5. So the area of the both ends will be 10 into half base times height. Now the length of the prism, the cross section, the other side of prism forms 5 triangles, having a width of 5 and the length of 12. So we shall have 5 triangles multiplied by length times width and 10. So we shall have 10 triangles, half base times height, plus 5 rectangles, length times width. Now a half the base length is 5 for each of the triangle, and the height is 2.5. That's a half of the base length, tan 54 multiplied by 10 plus 5 multiplied by 12 multiplied by 5. So if we simplify, we get that the pentagonal prism has an area of 386 centimeters square. A tailor had a piece of cloth in the shape of a trapezium. The perpendicular distance between the two parallel edges was 30 centimeters. The length of the two parallel edges were 36 and 60 centimeters each. Calculate the area of the remaining piece of the cloth. Now, I made a mistake jotting that question, but understand it like this. The tailor had a trapezium, and out of that trapezium, he cut out a circle of radius 14. Having cut a circle from that trapezium, what area was remaining of the cloth? We take the area of the trapezium less the area of the circle. So the area of the trapezium is a half base, half height into A plus B, and the area of the circle he cut. It was not a circle, actually it was a semicircle. It's a half pi r squared. So simplifying, putting the values there, you get that after cutting a semicircle from that trapezium, what remained of the cloth is 1,132 centimeters squared. The figure below represents a conical flask. The flask consists of a cylindrical part and a frustum of a cone. The diameter of the base is 10 centimeters, while that of the neck is 2 centimeters. The vertical height of the flask is 12 centimeters. Calculate correct to one decimal place the slant height of the frustum, the height of the smaller cone that was cut off to make the frustum part, and the external surface of the flask. Now the original cone had a radius of had a height of, let's say, x plus 10. Now the cone that was cut off automatically now will have x. Now if we relate, we have the bottom radius as 10, the upper radius as 2. If we relate to now the height, so 10 will represent the height of 10 plus x, and 2 will represent the height of x. That is using the linear scale factor. So we find that x is 2.5. Now having found x is 2.5, we can now find the slant height of the frustum. It means we have to get the slant height of the original frustum less the original cone less the smaller cone that was cut, so that we get the frustum. So the original slant height of the cone was 13.4, and the cone that was cut, its slant height was 2.6. So the slant height of the frustum is 10.77 centimeter. The surface area of the smaller cone that was cut from the frustum, how do we get it? It is taken as pi r l. Now we know pi, we know r is 2 centimeters, we know l, we had gotten the slant height to be 2.5. So if you do that, you'll get it, and we get it to be 2. You get the slant height of the smaller cone to be 2.7 centimeter. It means we found the height. We found the height to be x, which was 2.5. Now we know the radius. The radius is 1 because the diameter is 2 centimeters. So we divide by 2 to get 1. Now remember the slant height. It's like it forms a hypotenuse to the radius and the height. So square the height plus the radius squared, get the square root, you get the height of the slant height of the cone. Now lastly, let's find the surface area of the flask. The surface area of the flask, we shall find it by taking pi r squared minus pi RL, pi r squared plus pi RL minus pi RL plus 2 pi R H. Now, equating those values, the values for what I have named, we find the surface area to be 294.12 centimeter squared. The garden is in the shape of a right angled triangle. The length of the shortest side is 17 meter and the area of the garden is 346.8 meters square. Calculate the length of the shortest side of the garden. Now, area of a triangle is a half base times height. Now we have been given the area. We know the height to be 17. Now let's calculate the base. The base is 4.8. Now, the longest side of a triangle is always the hypotenuse. And using the Pythagoras theorem, if we have the base and the height, we can get the hypotenuse. So the hypotenuse is c squared is equals to a squared plus b squared. Now a squared, which is the base, 17 squared, b squared, which is the height, is 40.8 squared. Solving, we get c is 44.2 meters. In the parallelogram WXYZ below, WX is equal to 10 centimeter, XY is equal to 5 centimeter, and angle angle WXY is equal to 150 degrees. Calculate the area of the parallelogram. Now, area of a parallelogram is taken as base height. Now, the base is 10. The height is 5 multiplied by sine 30. When we solve, we get the area as 25 centimeter squared. In the trapezium PQRS below, PQ is 8 centimeter and SR is 6 centimeter. If the area of the trapezium is 28 centimeter squared, find the perpendicular distance between PQ and SR. Now the area of a trapezium is taken to be half the height into A plus B. We have been given the area as 28, so we have a half into the height which we are to find, we are not given, into A and B are the perpendicular lengths, so it is 8 plus 6. And now solving for H, we find that H is 4 centimeters. A chord of a circle 7 centimeter long subtends an angle of 60 at the center of the circle. Determine the area correct to 2 decimal places of the major segment of the circle. So the major segment of the circle will be 360 degrees minus 60. So it will be 300 over 360 multiplied by pi r squared. Solving, we get that the area of the major segment of circle is 128.33 centimeters square. In the quadrilateral ABCD, AD and CD are equal to 6 centimeters, and BA and BC are equal to 12 centimeters. Angle ADC is 300 degrees. calculate correct to two decimal places the area of the quadrilateral ABCD. Now, if you take ABC forms a triangle. Now, ADC also forms a triangle similar to ABC. To get the area of quadrilateral ABCD, we have to get the area of triangle ABC, then subtract from it triangle ADC. Now, since those triangles are similar, it means that angle ADC and angle ABC are equal. Now look at this way. This angle ADC is 60 because angle ADC is 300 on the other side. Now the side of the triangle ADC, it will be 60. Now AD is 6 centimeter, CD is 6 centimeter. Automatically it means AC is also 6 centimeter. So the smaller triangle ADC is an equilateral triangle. Now we can find the height of that triangle ADC, taking AC as the base. So we shall divide that base into half, so that we have the height, and we shall take any side, AD or CD, to be the hypotenuse. So having the hypotenuse and half the base, the height shall be 6 centimeter squared less 3 centimeter squared, and then get the square root of the answer. We get the height of that triangle ADC is 5.1961 centimeter. Now the height of triangle ABC, having also the base of 6, which you have divided into 2 to get the base for which the height is formed. We get it to be the hypotenuse being 12, we square it, minus the base with 3, we square it. The height we get it to be 11.16190. Now the area we shall get a half BH, uppercase H, meaning that we are finding the area of triangle ABC minus the area of triangle ADC, which is a half base height H in a lowercase. Now substituting the value, we have all the values. We have the base for all the triangle is 6. We have the height for the bigger triangle to be 11.6 and for smaller one to be 5.2. Solving, we find that the area of quadrilateral ABCD is 19.27 centimeter. A triangle ABC is such that AB is equal to 11 centimeter, BC is equal to 8 centimeter, and angle ABC is equal to 53 degrees. Calculate the area of the triangle correct to two decimal places. Now area of that triangle can be taken to be a half base height sin theta. Now a half multiplied by the base, which is 6, and multiplied by 11 sin 53, we get the area of that triangle. So that triangle, its area is 35.14 centimeters square.